Hello students and welcome to my channel Sriram Edutalks. In today's class, we are going to continue with the formation of ray diagrams for convex and concave lenses. In my previous video, we have already learned how to draw the various possible cases of ray diagrams in case of concave and convex mirrors. So today let us start with the lenses part. Now, first of all, we are going to do convex lenses, for which again I have 6 possible cases wherein I am going to keep the object in front of the convex lens at 6 different positions. So let us start with the first case, that is when the object is kept between center and f dash. So the object is between C and f dash. First ray, which is parallel to the principal axis, after refraction pass through principal focus, and another ray I am taking passing through C goes undeviated. Now, these two rays, as you can see, are diverging and they are not going to meet on this side. So I am going to produce them back behind the lens and see where they are meeting. So when produced backward, these two rays meet at this point. That means here our virtual and erect image of the object will be formed. So I can say that the image in this case is formed same side of object, that is, it will be formed on the same side where the object was kept. It is virtual. Any image which is going to be formed on the left of the convex lens will be virtual, and on this side will be real. It is above principal axis, so erect, and we can see it is magnified. So this is one of the most important cases of convex lens. The image formed is on the same side, virtual and erect and magnified. Let us move to the second case. Now I have kept the object at the focus f dash. First ray parallel to the principal axis. After refraction passes through focus, and another ray passing through C will go undeviated, and as we can clearly see, these two rays after refraction are getting parallel. So that means the image in this case will be formed somewhere very far off from the lens, that is at infinity. So I can say that here when object is kept at focus, image is formed at infinity. Now it is below the principal axis and on the right of the lens, so it is going to be real and inverted. Real images are always inverted, and as it is going to be formed far off somewhere here, I can say that it is going to be highly enlarged or highly magnified. Right. Third case. I've taken the object even farther from the lens, that is between f dash and 2f dash. The first ray, as usual, parallel to the principal axis. After refraction passes through focus, and second ray passing through C, going undeviated, and the two rays after refraction are meeting here. So I'm again getting a real and inverted image, slightly magnified and formed beyond 2f. The image here is formed beyond 2f. It is again real and inverted, and it is slightly magnified. Right. Fourth case. This is again interesting. Now, when the object is kept at 2f dash, now first ray I am taking parallel to the principal axis. After refraction passes through focus, and second ray I am going to take passing through optical center C, they both surprisingly will be meeting at 2f only. So we have to be a little careful while drawing this, as they are going to meet exactly at 2f, and will be of the same size as the object was. So here in this case, when the object is at 2f dash, image is also going to be formed at 2f. It will be real and inverted as usual, and will be of the same size. Very important. Moving on, we have the fifth case, that is when object is kept beyond 2f dash. So again my first ray parallel to the principal axis, passing through f, and another ray passing through C. After refraction, they are meeting somewhere here, that is between f and 2f. So I can say that image here is formed between f and 2f. It is real and inverted, and it is slightly smaller in size, so it is diminished in size. Finally, case number 6, when you keep the object even farther from 2f dash, that is somewhere very far off from the lens at infinity. So as we did in mirrors also, if the object is very far off, that is at infinity, the light rays coming from it before reaching the lens will become parallel, and so they all will be converging or meeting at exactly the focus. So when the object is kept at infinity, the image is formed At focus, it is real and inverted, and it is highly diminished, or you can say point sized. So it's going to be very, very small. We can say that it is highly diminished. Okay, so now let us move to concave lenses. We have just one possible scenario in case of a concave lens, that is when we keep the object anywhere in front of the lens, that is between optical center and infinity. If we keep the object, then suppose this is the first ray I am taking parallel to the principal axis. Although it is going to go this way, but I have produced it back, so it's going to pass through focus, and another ray passing through optical center will go undeviated, and here the diminished image of this object is going to be formed, that is between C and F. So if you keep the object anywhere in front of the concave lens, the image is always going to be formed between the optical center and the focus, and it will be always diminished, virtual and erect. So here in this case, the image is formed between C and F. Always it is going to be virtual and erect, and it is going to be diminished, always smaller than the object size. Right. If I try to generalize this situation, that is, if I say that now instead of keeping the object here, if I move it even farther here, then the image will again be formed between C and F, but as I move the object farther from the optical center, then the image will become closer to the principal focus. That is, the image will keep on moving towards the principal focus and will also be getting smaller and smaller in size. Now, so much that we can suppose that if the object is kept somewhere at infinity, so these are two parallel rays coming from an object kept at infinity. So if you keep moving the object farther and farther away, that is, if you move it at infinity, the image will become smaller and smaller in size, so much that at some point in infinity, the image is going to be formed exactly at focus and will be point size, highly diminished. So if we keep moving the object away, that is, here I have kept the object at infinity, image formed will be at focus only. It is going to be as usual virtual and erect, and it's going to be highly diminished, or we can say point sized. Okay, so that is all about concave lenses as well. Hope you must have liked and understood the entire topic. That is all for today. Come back again for more such videos. Till then, take care, goodbye, and yes, keep watching Sriram Edutalks.